Have you ever found yourself just standing on a busy city street, craning your neck to look all the way up at one of those towering, modern glass buildings, and you just wonder, what exactly makes that outer skin so special? I mean, we see these massive, gleaming structures every single day, right? But we rarely stop to actually think about the incredible engineering that's wrapped right around them.
So what is the big deal with that outer skin? Well, welcome back to QMS with Naveen. In this explainer, we're going to peel back the layers of modern construction to see how the entire outer face of a building, what architects and engineers call the facade, is honestly so much more than just a pretty exterior. It's actually a highly active, totally dynamic system. Okay, let's dive right into this. Here's a quick look at what we're covering today. First, we'll look at the modern building envelope. Then, the vital functions of a facade. After that, we'll compare traditional versus curtain wall systems. And finally, we'll break down the key components of the facade.
Starting us off, Section 1, the modern building envelope.
Now, what's really fascinating here is the clear contrast between the past and the present. You see, traditionally, when builders talked about a facade, they were pretty much just talking about the front elevation, literally just the face of the building where the main entrance was. It was basically the decorative front door of the whole structure. But look at the modern definition. Today, especially when we're dealing with high-rises and massive commercial buildings, the facade refers to the entire external envelope, everything except the roof. It's this massive continuous wrap. And because it covers so much surface area, it requires incredibly strict quality control to make sure there are absolutely zero weak points anywhere in the system.
So the really crucial takeaway is this modern definition. We need to start thinking of the facade as the main exterior face, essentially the outer skin of the building. And why call it a skin? Well, because exactly like our own skin, it actively responds to its environment. It serves as a serious protective shield against the outside world, a critical energy control layer that regulates what comes in and out, and of course, it's the primary architectural identity of the building. It really is a living, breathing barrier.
Moving right along to Section 2, vital functions of a facade.
So there are 4 critical roles a facade plays, and a successful building has to absolutely nail every single one of them. First up is aesthetic impact. The facade gives a building its personality, its visual identity. It's the big statement the architect is making to the city. Second is weather protection, which means actively defending the interior from rain, wind, heat, and really intense UV exposure. Third, we have thermal performance. The skin is specifically engineered for insulation and energy efficiency, keeping the building cool in the summer and warm in the winter. And fourth, and you'll definitely want to pay attention to this one because we're about to see exactly what it means, is structural performance. This is absolutely vital when we start building upwards.
To give you a real-world idea of what these high-rises actually face, think about skyscrapers in places like Miami. They have to withstand Category 5 hurricane winds pushing over 150 miles per hour. Meanwhile, buildings in Dubai are battling scorching 120-degree heat that could literally warp lower-quality materials. At these extremes, the facade doesn't just sit there. It physically bends and flexes with that immense wind pressure to stop the glass from shattering. It even has to absorb seismic movements from the earth itself. So it's a high-stakes, highly engineered shield protecting everyone inside from some very real, very powerful elements.
All right, Section 3, traditional versus curtain wall systems.
And this brilliantly illustrates the massive leap in engineering we've made over the centuries. Over on the traditional load-bearing side, think of your classic brick or heavy stone buildings. In those older systems, the external walls are actually doing the heavy lifting. They're physically supporting the weight of the floors and the roof. But then we look at the modern curtain wall. This is a total game changer. Because curtain walls don't hold the building up, they can be incredibly thin and lightweight. That's exactly what allows for that massive floor-to-ceiling glass that traditional brick could just never support. Plus, while traditional walls tend to absorb and trap heat, modern curtain walls use something called thermal breaks. This is advanced engineering that physically separates the outside metal from the inside metal, stopping heat transfer dead in its tracks. So instead of holding the building up, this external skin is literally hung from the internal structure of the building. Kind of like, a curtain hanging in front of a window.
And let's see how this builds into even more specialized modern variations. Take the double-skin facade, for example. Building on that curtain wall concept, engineers take 2 layers of glass and leave an air cavity right between them. It's a really brilliant design because it creates this buffer zone that allows for highly advanced insulation and dynamic ventilation. By doing this, that simple buffer zone can actually slash a building's cooling costs by a massive percentage. It totally proves that the facade easily pays for itself over time. It's basically the ultimate evolution in energy control for modern buildings.
Let's wrap things up with Section 4, Key Components of the Facade.
Okay, so there are three main pieces to this giant puzzle. First, we have the cladding, or the siding. This is your outermost protective layer that actually touches the elements out there. So your glass, your stone, or materials like ACP, which stands for aluminum composite panel. Next is fenestration. It's a fantastic architectural term, but it really just means the specific arrangement of windows and doors within that outer skin. From a practical standpoint, though, the sealing quality around these fenestrations is actually the #1 failure point if the engineering and quality management aren't absolutely perfect. And finally, the parapet. This is that low safety wall you'll find at the edges of the roof or along the boundaries of balconies. Together, all these components integrate into the unified, complex systems we've been examining.
So the next time you walk past a towering skyscraper, just take a second to look up. That sleek glass isn't just sitting there looking pretty. It's actively flexing against gale force winds, it's deflecting intense solar radiation, and it's shielding hundreds of people in a perfect climate-controlled bubble. And it really begs the question, as our materials get smarter and our engineering gets even bolder, will the facades of tomorrow eventually generate more energy than the buildings themselves actually consume? Now that's something to think about.